So to work with absolute value equations and inequalities, you can solve them similarly to how we have worked with equations, but since there's that absolute value piece, you need to think about it as whatever is inside this chunk has an absolute value of 3. So if you just think about that for a second, if you don't even know what is in here, if we don't know what's inside these absolute value chunks, or the absolute value bars, but we know that whatever's in there has an absolute value of 3, you know that that expression then, whatever's there, is equal to 3 or negative 3, because on a number line, absolute value refers to a number's distance from 0. So if here is 3, it's 3 away from 0, and negative 3 is 3 away from 0. So it doesn't really matter initially what's inside or hidden behind this box. Whatever is there is going to either equal 3 or either equal negative 3. So to keep that in mind, it'll help you solve this equation. So I know then that x plus 5 either is going to equal a positive 3 because it's got an absolute value equal to 3, or that x plus 5 is going to equal a negative 3. So for each of these cases with absolute value, you're going to have two equations, one set equal to that positive number and the other set equal to the negative number. And then you just solve each equation. So you subtract 5 from both sides to get x equals negative 2. And then over here, subtracting 5, and you get x to equal a negative 8. So notice the two numbers are different. It's not just a positive 2 and a negative 2. That's a common misconception that students will do. They'll solve the first equation with it equal to a positive 3 like this, but then they'll get this answer and just automatically assume that the other answer is going to be the opposite of that. Make sure you solve both equations. And it's clear in this case that negative 2 would work for x because negative 2 plus 5 would be 3, and the absolute value of 3 is 3. If you check it with negative 8, if I were to plug in negative 8 plus 5, that would equal a negative 3, and the absolute value of a negative 3 is also equal to 3. So looking at another example, this time the chunk that we have inside our absolute value bars, it's not by itself. We have this number 2 multiplied on the outside. In order to set up your two equations, you need to have that absolute value piece alone. It can't have anything multiplied by it on the outside or added or subtracted that's on the outside of those bars. So the simple first step of this is just get this piece by itself. Right now it's multiplied by 2, so you want to undo that multiplying by 2 by using the inverse operation of multiplication, which is division. So 2 divided by 2 equals 1. We're left with the absolute value of x plus 7. And then 48 divided by 2, that equals 24. So now our equation looks just like the one we previously did. So I know that whatever is in here has an absolute value of 24. So that expression could equal a positive 24 because 24's absolute value is 24. Or that expression could equal a negative 24 because the absolute value of a negative 24 is also 24. And then you just solve this equation to get x is equal to 17. And then over here, subtracting 7, you end up with x is equal to a negative 31. So again, note it's two different answers. They're not just opposites. So the same thing now works with inequalities. So keep in mind how we would solve this as an equation. The inequality piece is solved very, very similarly. It just has a slight separate step. So let's see if you notice where it is. So initially, you're going to set up your two equations because what's inside this chunk could equal a positive 48. Or it could equal a negative 48. So you set up your two cases. One with the expression equal to a positive 48, the other equal to a negative 48. So this should be the same, but look what happened over here. When we set it up to a positive 48, notice that the inequality is the same. When you change it so that it's equal to a negative 48, notice what happened with that inequality. You have to flip it. When you have it set equal to the negative number for the absolute value, you have to flip the sign. Everything else is solved the same way. So you're going to add 6 on both sides of each of the equations. So because you're trying to get 3x by itself in each of these. Once you add 6, note how the equations look. 3x equals 55. 3x equals negative 42. And then on the inequality side, the numbers are the same, but we have an inequality symbol. And so this one is greater than or equal to a negative 42. So then we want x by itself, so we divide by 3 on each of those steps, and then we end up with our answer. So note how the answers look very similar. The methodology is very close to the same thing. It's pretty much the exact same steps for each thing. The main difference is this is an inequality. So when you set up your two cases like this, one that's equal to the negative, you have to flip that sign. Otherwise, everything else is exactly the same. One last note, we've talked about conjunction and disjunction with our inequalities, and that a conjunction, if it's less than or equal to, this is just kind of a shortcut way of knowing if it's going to be a conjunction or a disjunction. So if your inequality uses less than or equal to, think of less than as being less than and is our conjunction. A disjunction is using greater than or equal to. So think of this expression greater than as great or is a disjunction. Less than and is a conjunction. It's just a quick way of differentiating between the two as you're working. And just to see it in action here, a conjunction, so x minus 2, absolute value is less than 2, and 8 minus b is less than or equal to 6. If you were to solve both of these, a conjunction, if you remember, the graph of these is an overlapping graph. So whatever the solution is, let's say this is our solution here, it's going to be an overlapping graph because it has to fit a solution for both inequalities. In this other example, a disjunction using or, graph on a number line, remember our graphs go in opposite directions. So the solution will fit one equality or the other. So disjunction graphs look like this, conjunction graphs look like this. If you're looking for additional practice problems in the reference guide link that's in the course, the page 152 has some more practice questions that you can try.